Hey everyone, and welcome to The Explainer. Today, we are diving into a totally fascinating, super complex, and, let's be honest, completely invisible world that is right beneath our feet. We're talking about the anatomy of a residential plumbing system. And to make this super concrete, we're zooming in on Fairfield, Ohio. Why Fairfield? Because its crazy mix of climate, soil, and aging houses makes it basically the ultimate, fascinating gauntlet for testing home infrastructure. It is literally man-made engineering battling it out against the relentless forces of nature. Let's get into it.
Okay, let's dive into this. Here is our roadmap for today. First up, Fairfield's unique plumbing challenges. Then, the anatomy of pipe failures, followed by the hidden rules of plumbing. After that, we'll look at the three-step repair process, and finally, understanding plumbing costs. We're going to uncover some hidden environmental dangers and, of course, get into the literal dollars and cents of home maintenance.
Section 1. Fairfield's unique plumbing challenges.
So if you think the pipes under your house are just, sitting there peacefully, think again. Local geography and wild weather act as these relentless antagonists, waging an absolute war on your plumbing. 95. That is the staggering average number of days temperatures in Fairfield drop below freezing every single year. Just imagine the immense repetitive stress that puts on a home's vulnerable water systems. You know water expands when it freezes, right? Which means any exposed pipes out in crawl spaces, attics, or exterior walls are in constant, severe danger of just snapping. The stakes are sky high the second that temperature drops. But the attack isn't just coming from the freezing air. It's coming directly from the earth itself. It's a classic showdown, expanding clay soil versus rigid underground pipes. See, Butler County is notorious for its heavy clay soil. When it rains, that clay acts like a sponge. It absorbs the moisture, expands dynamically, and shifts with just unbelievable force. And then when it dries out, it shrinks right back down. Meanwhile, your underground sewer lines are completely inflexible. So as the earth is continuously breathing and shifting around them, those poor rigid pipes inevitably sag, shift, and eventually break. And then, adding to that whole geographical challenge, you have the historical makeup of the area. Beautiful, older neighborhoods near Pleasant Avenue and Harbin Park, the ones built back in the 50s, 60s, and 70s, they are actually sitting on a massive hidden hazard. A lot of these homes were built with galvanized steel supply pipes, and the truly insidious thing about aging galvanized steel is that it corrodes from the inside out. So the outside might look perfectly fine, totally normal, while inside, rust is literally choking off your water pressure until the whole system just fails completely without any warning. Crazy, right?
Moving right along to Section 2, the anatomy of pipe failures.
So, what's actually causing these systems to catastrophically fail? We've got four main culprits tearing up your plumbing. Think of this as a relentless, year-round assault on your home's infrastructure. First, you've got hydrostatic pressure from heavy spring rains. Then, winter brings those brutal freeze-thaw cycles we talked about. All year long, hard water mineral deposits are just slowly clogging up your fixtures. And finally, tree root intrusion. Especially in older clay sewer pipes, tree roots will literally seek out the moisture and bust right through the joints. It's like nature is always trying to reclaim its territory.
Let's pause for a second and talk about hydrostatic pressure. I know, it sounds super technical, right? But it's actually absolutely crucial to understand. Basically, it's groundwater that gets forced through basement floors and foundation cracks by saturated clay soil. When those heavy spring rains drench the area, that clay soil we mentioned acts like a giant sponge. It traps the water, creating an unbelievable amount of physical weight and pressure pressing right up against your foundation. The water literally gets squeezed until it finds the path of least resistance, which, unfortunately, is usually shooting right up through your basement drains. No way you want to deal with that.
Section 3. The hidden rules of plumbing. Now, what's really interesting about this slide is the fascinating, highly engineered science that plumbers actually use to combat nature. So, let me ask your inner DIYer a quick question. Can a drain pipe have a 90-degree elbow? The answer is yes. They are actually allowed by code in specific situations. But here's the secret. While it's technically allowed, if you string multiple 90-degree sharp turns together on a horizontal run, you are creating absolutely devastating clog points. Think about it. Water and waste need smooth momentum. Sharp, abrupt angles totally destroy that flow. And that is exactly why older homes with outdated, twisty layouts suffer from those constant, agonizing backups. To prevent those literal nightmares, professional design relies on rules like the 135-degree rule. This rule mandates that any drain line changing direction more than 135 degrees absolutely must have a cleanout access point installed for future maintenance.
Proper design basically anticipates that clogs are gonna happen. By putting a cleanout at those complex junctions, plumbers make sure they always have a way to snake the line. This stops a simple, temporary clog from turning into this massive, expensive disaster where they have to literally tear open your walls.
And check this out, because this is just pure math in action. The 1.414 rule. Let's say a plumber is running a pipe and hits an obstacle, like a floor joist, and they need to bypass it using a 45-degree angle. They don't just eyeball it and guess the pipe length. No way. They measure the offset distance and multiply it by 1.414. This brilliant trigonometric principle determines the exact, precise pipe length needed. It guarantees perfect alignment and prevents forced, weakened joints that are definitely going to leak down the line. I just love how incredibly precise that is.
Section 4, the 3-step repair process. This is all about the structured, professional response needed when things actually break. Because, hey, chaos can be managed.
The really crucial takeaway here is that professionals don't just panic and react when a pipe bursts. They follow a strict protocol. For example, Keystone Plumbing uses this exact 3-step process. Step 1, schedule and diagnose. They aren't just staring at a puddle on the floor. They bring in high-tech video cameras and thermal imaging to look way beyond the surface symptom and actually cure the underlying disease. Step 2, professional repairs using high-quality, code-compliant materials. And finally, Step 3, final testing and documentation. They thoroughly pressure test the entire system before they even think about leaving, so you are left with complete peace of mind.
Section 5. Understanding plumbing costs. Let's pull back the curtain and get some real financial transparency here.
So, what should you actually expect to pay? Here are the exact numbers for the Fairfield area, breaking down the fair market value. For standard repairs, you're looking at an hourly rate somewhere between $85 and $150. Now, if your basement floods at midnight and you need an emergency fix, that rate jumps to about $150 to $250 an hour. You're also typically going to see a trip fee or diagnostic fee of about $50 to $100. Knowing these baseline numbers is absolutely crucial so you never overpay. Oh, and here's a great pro tip. That diagnostic fee is actually very often applied toward your final repair cost if you decide to hire them for the job.
However, the hourly rate definitely isn't the whole story. You've got to be aware of the hidden costs that can easily bloat a project budget by like 15 to 20%. We're talking about mandatory county permit fees, the physical costs of repairing your drywall or flooring after they access those hidden pipes, disposal fees for lugging away heavy old fixtures, code-mandated upgrades if your current setup is out of compliance, and of course, water damage restoration. Understanding all of this up front means you are never caught off guard once a wall gets opened up. I also really want to highlight this stark warning directly from our source material. Avoid contractors demanding full payment up front or pushing unnecessary upgrades. Seriously, if a contractor uses high-pressure tactics or demands all the cash before they even pick up a wrench, that is a massive red flag. Always demand itemized written estimates that clearly separate the labor from the materials. Reputable professionals are going to educate you, give you your options, and let you decide. Always trust your instincts on this stuff.
As we wrap up this explainer, I want to leave you with a provocative question to really ponder. Do you truly know what condition your home's hidden pipes are in right now? We've explored the aggressive environmental forces constantly attacking your home and the incredible engineering required to protect it. I strongly urge you to think proactively about your own invisible infrastructure before it turns into a total midnight emergency. Thank you so much for joining me to decode the anatomy of a plumbing system. Stay curious, stay proactive, and we will see you in the next explainer.